Hi, today we're going to look at rational expressions in terms of adding and subtracting fractions with rational expressions here. Now, there's something we need to talk about. It's called the least common multiple. And I'm going to demonstrate this idea. This is not exactly how it goes, but it gives you sort of the idea of what you have to do. And the least common multiple has to do with getting the denominators the same. Let's say that we have three boxes, a green box, a red box, and a blue box. And we're going to have some of our friends come and join us here. We have Newton on our right and Hilbert on our left. Now, if we take these two characters and stuff them in these boxes here, in which box will they just fit? What's the smallest box that they will just fit into? So let's try the green box. Oop, there goes Hilbert. Now let's put Newton on top of him. Nope, this box is too big. So let's go out and let's check out the blue box. So we go over here, and in goes Hilbert, and then in goes Newton. Too big, or too small. This is sort of a Goldilocks thing here. Now, out goes Hilbert. In goes Hilbert. And then along comes Newton here. And goes. A perfect fit. The red box is a perfect fit. Just sort of keep that idea in mind as we talk about the least common multiple. Here's two numbers, 30 and 20. What is the simplest number that contains the factors of each of these numbers? Now we can use prime numbers just to start out with this. So look at all the factors, the prime factors of each one of these numbers. Pick all the different factors that are between these two numbers here. There's a 3 and there's a 5. In this case, there's a 2 and a 2 squared. Pick the one with the largest exponent, which is 2 squared. Now multiply 2 squared times 3 times 5, and it's 60. Both 30 and 20 will both just divide into 60. They're factors of 60. Now, in this case, we have some polynomials. What's the simplest polynomial that contains the factors of each of these polynomials? Well, with the 4 and the 12, you could use some prime numbers there, and we have the x's and y's. Pick the in each case we have 2 squared. We can pick out 2 squared. We pick out 3. Now, in the case of the x's and y's, pick out the ones with the largest exponents. In this case, an x squared and a y to the 4th. So in the end, we get 12x squared y to the 4th. Next example. What's the simplest polynomial that contains the factors of each of these polynomials? So let's do the factoring here, and so we can pick out there's a 3 and there's a 5, and pick out the 2 to the 4th because it's the larger one, and then there's x to the 5th that has a larger exponent, and a y cubed. Multiply those together, you get 240 times x to the 5th y cubed as your least common multiple. All right, now let's apply that to adding two fractions together. We'll just start out with simple fractions here. A 30 and a 10. What's the least common multiple? What's the simplest number that contains factors of both 30 and 10? And that's 30. So in the second fraction, we'll have to multiply 3 times the numerator and denominator to get the denominators the same. Be sure to do the numerator and the denominator, or we'll lose the value. So in the end, we get 11 over 30. Next problem here. Let's find the least common multiple here for our two denominators here. It looks like it's 6x squared times x minus 2, if you use what we just went over. All right, so in the first fraction, we're going to have to multiply a 2x times the numerator and denominator. And in the second fraction, we're going to have to multiply x minus 2 times the numerator and denominator. Now, you can work out the denominators there. You get everything that's in the numerators over 6x squared times x minus 2. Now the x minus 2's cancel out, and you're left with negative 4x plus 3 over 6x squared. In this problem here, it looks like our lowest common denominator there, or least common multiple, is 6x squared y. So in the first fraction, multiply 3x squared times the numerator and denominator, and in the second fraction, a y times the numerator and denominator. So in the end here, we get negative 9x squared y plus 3x squared y over 6x squared y, and those the numerators just add together there, and this all just work out to be a negative 1. Next one, it looks like 10a squared b is going to be our common denominator. So in the first fraction, multiply a 2a times the numerator and denominator, and then you'll just get 4a minus 3 over 10a squared b. Now, our last problem here. Let's find the least common multiple between 12x and 9x. It looks like it's 36x. So we're going to have to do something to all the numerators and denominators. First fraction, multiply a 3 times the numerator and denominator. Second fraction, a 4. And now we can subtract the fractions there, and we'll get all those terms in the numerator over 36x, and just sort of combine terms, and we'll get negative 6x minus 19 over 36x. Thank you.